Hi there, my name is Mariana Quintero, and this is my presentation for the mechanism activity. This reaction begins with an acid-base reaction to prepare a better nucleophile. The sodium and hydrogen act as ions because they're a metal-non-metal pair, which tend to transfer electrons instead of sharing. Electrons are transferred from metal to nonmetal, so when hydrogen is with a metal, it is actually negatively charged. However, it is not very electronegative, so it acts as a very strong base. The best acid on the molecule is the OH molecule because the oxygen is very electronegative and makes the OH bond very polar, with hydrogen having a very partial positive charge, which is attractive for the base. In an acid-base reaction, a lone pair of electrons flow from the base to a hydrogen atom by making a single bond. At the same time, the hydrogen breaks its bond with the acid so that it can be removed from the acid. The electrons that were part of the bond between the hydrogen and the acid flow to the oxygen atom of the acid as a lone pair, making it negatively charged. After the acid-base reaction, the hydrogens are released as hydrogen gas, which makes this reaction essentially irreversible. The oxygen is now negatively charged, which is called an alkoxide, and it is a much stronger nucleophile. The most electrophilic atom on the molecule is the carbon on the carbon-bromine bond, because of the higher electronegativity of the bromine, which polarizes the bond and makes a partially positive charge on the carbon, which attracts electron density from the nucleophile. Because the alkoxide is electron-rich and the carbon from the carbon-bromine bond is electron-poor, the electrons from the oxygen flow to the carbon. However, because the ring is rigid and cannot rotate, the oxygen must attack from the top side where it is already located. This is more favorable because this is an SN2 mechanism, which must undergo backside attack because the nucleophile is attacking at the same time that the leaving group is leaving. This typically leads to a transitional state with a trigonal bipyramid geometry with the nucleophile 180 degrees away from the leaving group. However, due to the shape of this ring, the geometry of the transition state might be slightly distorted, but still be favorable because the ring is rigid. Due to this transition state, this concerted mechanism results in only one stereochemical product. It forms an epoxide with the oxygen above the ring in the outward orientation it began in. Once the reaction is completed, acid can be added to quench the reaction. The hydrogen anions will react with the acid to form hydrogen gas, and any unreacted alkoxides will be protonated and returned to their original form as an alcohol. Without a strong base to initiate the first step, the reaction will stop.